Namaste. Welcome to the lecture series on the subject Basic Thermodynamics, Module 3, Part 2, Entropy, Lecture number 14. Myself, Dr. Satheesh Kumar, Associate Professor of Mechanical Engineering, Canara Engineering College, Benjanapada. So the contents for this topic are numerical on entropy calculations. So we will continue from the previous lecture. A reversible engine, as shown in figure, during a cycle of operation draws 5 megajoules from the 400 K reservoir and does 840 kilojoules of work. Find the amount and direction of heat interaction with the other reservoirs. So this is a question diagram you can see here. So a heat engine is interacting with the 4 reservoirs here. So one reservoir is at 200 Kelvin, another reservoir is at 300 Kelvin, and one more reservoir at 400, and then 3 reservoirs, not 4, and it does 840 kilojoules of work. Now here the heat interaction with the 400 Kelvin reservoir is given as 5 megajoules here, 5 megajoules, and work done is given as 840 kilojoules. So now one is in kilo and one is in mega. This mega you can multiply by 1000 and you can convert into kilo, so it becomes 5000 kilojoules, or this you can divide it by 1000, that is 840, you can convert into mega. So anything is possible, so generally we go for the kilojoules. Now, so there are 2 more heat interactions with the reservoir at 300 Kelvin and reservoir at 200 Kelvin. So you have to find out the magnitude and the direction of this heat interaction with these 2 reservoirs. So let us assume that Q2 and Q3 are the heat rejected by the engine. Now you have to assume a direction for this. So heat rejected means these 2 are the directions. So anyhow it is absorbing from 400, you can see the arrow mark, it is absorbing 5 megajoules. So part is converted into work, so it has to, one rejection has to be must. Now both you can assume it as rejected, and if both you get the positive answer, so then your assumption is correct. Suppose if you get reverse, so your assumption is wrong, then you have to change the direction. So Q2 is with the 300 Kelvin reservoir and Q3 with the 200 Kelvin reservoir. So from the Clausius theorem, we know that cyclic integral of del Q by T is equal to 0. So for a cycle, the ratio of heat transfer to the absolute temperature is always equal to 0. That means you can write here, so there are 3 heat interactions, Q1 taking place at T1, Q2 taking place at T2, Q3 taking place at T2. You see, from each of these reservoirs which are at different temperatures, so different amount of heat is transferred. So ratio of that heat to the temperature at which this heat transfer takes place, that means Q1 by T1 plus Q2 by T2 plus Q3 by T3 is equal to 0. So this is the meaning of cyclic integral of del Q by T is 0 is equal to 0 for this heat engine cycle. And all of you know that now since we assumed some direction here, heat rejection from 200 and 300 Kelvin, so one input is there here Q, and it does 840 kilojoules of work. So Q1, this is Q1, so Q1 is coming in and W is going out, so Q1 minus W is what it is rejecting to 2 reservoirs, that is Q2 plus Q3. So Q minus W, Q1 minus W rather, is equal to Q2 plus Q3. This is simple mathematics. So whatever entering in should be what is going out, or in other words you can write as Q1 is equal to W plus Q2 plus Q3 also you can write, because 1 is entering, 3 are going out, so that you can write on one side also, no problem. And now previous equation if you consider, that is Q1 by T1 is plus Q2 by T2 plus Q3 by T3 is equal to 0. In that Q1 is 5 megajoules, T1 is 400 Kelvin, T2 is 300 and T3 is 200, and using negative sign for the heat rejected and positive sign for the heat absorption. So you have to consider engine as the system. So whatever the engine absorbs is positive, engine rejects is negative. So now is substituted in joules. So it is 5 into 10 to the power 6, mega is 10 to the power 6 here. Okay. So Q1 by T1. Now rest two are rejected. So that is minus and minus. Q2 by T2 and Q3 by T3. The 300 and 200 are T3, T2 and T3 respectively. Now if you simplify this equation, you will get 2Q2 plus 3Q3 is equal to 75 lakhs. Okay. Okay, if you substitute in joules, you will get so much. Suppose if you substitute in 10 to the power 3 here, so then you will get it less number, around 7500 kilojoules. Okay, so that is your choice. Either you can substitute in 10 to the power 6 or 10 to the power 3 also. Okay, but prefer to use same unit throughout. That is my suggestion. Okay, and now equation 2, what is that? Q1 minus W is equal to Q2 plus Q3. So Q2 plus Q3 you will get Q1 minus W. So everything is substituting in joules. So you will get 416,000 joules. So here also it is joules. So here also it is joules. Now you see you have two equations. One is 2Q2 plus 3Q3 is equal to so much, and Q2 plus Q3. So now you know how to simplify two simultaneous equations and to find out two unknowns. And after simplifying, so you will get Q3 is equal to 0.82 megajoules and Q2 is equal to plus 4.98. This is minus, you see, minus 8.82 megajoules and Q2 is plus 4.98. So now the direction of Q2 which is assumed as rejected is correct, whereas Q3 you got as negative answer. That means already you have taken it as negative here. You see, Q2 and Q3 already you have taken it as negative, but if you get the answer is again negative, that means your assumption is wrong. It should have been positive. That means you have to change the direction of Q3. See, you assumed negative, already you have to take it as negative. That means answer you should get as positive only. But if you get the answer negative, that means your assumed direction is you have to change. So this is how you have to change the directions here. So here you see, in fact we assumed both are rejected, but now we proved that only Q2 is being rejected. You see, arrow mark remains same, whereas Q3 I am reversing the arrow mark because Q3 I got negative, so I have to reverse the arrow mark. So this is how you have to complete the problem. Okay. Okay, now let us solve this problem. In fact it is a mixing problem. 2 kg of water at 80 degrees Celsius is mixed adiabatically with 3 kg of water at 30 degrees Celsius. I think it's simple, some common sense here, easy to understand. You have 2 kg of water which is at 80 degrees Celsius, and you are mixing or you are adding like you are mixing hot water with cold water. So 2 kg of hot water at 80 degrees Celsius mixed with 3 kg of cold water at 30 degrees Celsius. Okay, so at a constant pressure of 1 atmosphere, find the increase in entropy of the total mass of water due to mixing, and Cp of water is given as 4.187 kilojoules per kg per Kelvin. So as all of you know, when two fluids, one at high temperature and one is at low temperature, is mixed, so you will get an equilibrium temperature which is between these two temperatures. Okay, let us find out from entropy principle. Now this is a diagram you can represent. So instead of writing M1, Cp1 and T1, so directly you can write as 2 kg here, and Cp of water is 4.187, that also you can write, and T1 is 80 degrees Celsius. Okay, so directly you can write the temperature. Similarly here 3 kg and Cp remains same, and this is at 30 degrees Celsius, so that is also possible. Okay, instead of writing M1, Cp1, T1, you can write the actual values inside the box. Okay, now subsystem 1, so 2 kg of water at 80 degrees Celsius, subsystem 2, 3 kg of water at 30 degrees Celsius, so and T1 is greater than T2. Okay, now let Tf be the equilibrium temperature of the mixture of the two subsystems, because which has to be between T1 and T2. So that is what, so Tf should be greater than T2 and less than T1, because T1 being the higher temperature, so the equilibrium temperature Tf should be less than T1, but it should be more than T2. So there is a common sense to understand that. Okay, Okay, now let us use the calorimetry principle, that is heat lost by the hot substance is equal to heat gained by the cold. So here this is water at 80 degrees Celsius. So initially at temperature T1, after mixing it becomes Tf. So delta T is T1 minus Tf. So M1 MCP delta T, MCP delta T. So M1 CP1 and delta T is T1 is 80 degrees Celsius. After mixing it becomes Tf. So delta T. Whereas this other fluid, which is at water at 30 degrees Celsius, its temperature is increasing. So final temperature is more than initial. So delta T becomes Tf minus T2. Okay. So M2 Cp2 into Tf minus T2. If we simplify this equation, you will get an expression for Tf as M1 Cp1 T1 plus M2 Cp2 T2 divided by M1 Cp1 plus M2 Cp2. Now since both are water and both have the same specific heat, in fact you can cancel these Cp terms from the both numerator as well as the denominator. Okay, Cp1 is equal to Cp2, so you will get M1 T1 plus M2 T2 by M1 plus M2. You see, this is the case only when both are having or both are the same fluid and same specific heat. Otherwise you cannot cancel. Suppose if water is mixed with some oil or some other fluid, so with the different specific heats, so then you have to write separately. Okay, so be careful about this. After substitution you will get it as 50 degree Celsius here. Okay, since you are substituting in Celsius only, so you will get Celsius. Suppose if you substitute in Kelvin, you will get it in Kelvin. Now better you convert this into Kelvin. It becomes 323 Kelvin before you calculate the entropy change of subsystem 1 and 2, because there the formula you have to use the Kelvin only. Okay. Now entropy change for the fluid subsystem 1, so its temperature is decreasing. So T1 to Tf, now it is written capital T1 and capital Tf because it is in Kelvin. Small t1 and small tf is Celsius. Okay. So T1 to Tf, M1 Cp1, Cp or Cp, both are water, Cp you can take dt by T. So this is a formula all of you are very familiar. So integration of 1 by T is ln T and applying limit, so ln Tf by T1. So all of you know this. So 2 kg, Cp is 4.187 for water. So this is what Tf is, I told you to convert into Kelvin here. So this is where it is used now. 323 divided by initial temperature is 353. So numerator is less, denominator is more. So it will be negative quantity, sure. No doubt about that. Okay. So entropy change for the fluid subsystem 2. So here temperature is increasing, so it should be positive. So T2 initial temperature of water, final temperature is Tf, same formula. Only thing is M2 you have to take. So M2 Cp ln Tf by T2. If you substitute, you will get 0.8028 kilojoules per Kelvin. So increase in the entropy of the total mass of water due to mixing, you have to add delta S1 plus delta S2. So that is entropy change of the subsystem 1 plus entropy change of the subsystem 2. So you will get it as plus 0.0591 kilojoules per Kelvin. Since it is an irreversible process, so entropy change of this total system should be positive for sure. Okay. Since delta S is positive definite, the mixing process is irreversible. Okay. Now let us take one more question. A steel tool of mass 0.5 kg at a temperature of 350 degrees Celsius is plunged into an insulated vessel containing 10 kg of oil at a temperature of 20 degrees Celsius. After some time, the temperature of the contents of the vessel becomes uniform. Okay, fine. Assuming the heat transfer to the surrounding or atmosphere to be 0 and none of the oil evaporates. So it is telling that there is no heat loss, as if it is in an adiabatic chamber. Okay. Evaluate the increase in entropy of the final contents of the vessel. Take Cp of oil as 1.88 and Cp of steel as 0.48. Okay. So two different substances. One is oil and one is steel. Steel having mass of 0.5 kg. It is hot steel which is at 350 degrees Celsius, is a piece of steel at a very hot heated steel piece, is plunged into 10 kg of oil which is at 20 degrees Celsius. So steel is 0.5 kg and oil is 10 kg, temperature is different and Cp values are given similar to the previous problem, only thing is two different substances. Okay. So write a table for steel and oil. So steel temperature is 350, mass of steel is 0.5, Cp steel is 0.48, T oil is 20, mass of oil is 10 kg. See, ensure that both are in the same units. For example, mass, if it is given in grams for one of the substance, you have to convert that also into kgs. That is very, very important. Okay, now let Tf be the final temperature or equilibrium temperature of the contents after mixing. That means when the steel tool is plunged into the oil and it attains equilibrium temperature. So you know that heat lost by the steel, because if its temperature is decreasing means it is losing heat. So it is taken by the oil, its temperature increases. So here temperature difference is Ts minus Tf, whereas here the temperature difference is Tf minus T naught. This is nothing but mass of steel into C of steel, here mass of oil into C of oil. So I won't elaborate much on this equation. It is similar to the previous equation which I used in the previous problem, wherein I elaborated about that. And Tf, you have the formula Ms C steel Ts plus M oil C oil TO divided by Ms C steel plus M oil C oil. So nothing is cancelling here. You have to substitute for everything and you will get the equilibrium temperature as 24.16 degree Celsius. Now entropy change for steel. See, once you find out the equilibrium temperature, especially in mixing problems, first you have to find out the equilibrium temperature using the same method what we did now. So then you have to find out the entropy change. Now steel entropy change, so same formula. So whenever the temperature change is there, you have to use the integration formula. Integration Ts to Tf, Ms C steel dt by T. So same integration, and since surely you will get a negative answer because steel temperature decreases. Okay. So entropy change of oil. So oil temperature is increasing from T0 to Tf. Okay. Similar formula, but only thing is the mass specific heat are for oil, and similarly you have to integrate that integration of 1 by T with respect to dt, L and T, apply the limits and substitute, and surely you will get the positive answer because for the oil the temperature increases. Okay. Now you have to find out the entropy change of the final contents of the vessel. So you have to add delta S steel plus delta S oil, and surely you will get a positive answer. Okay, that is minus 0.178 plus 2.26504 is equal to 0.08704 kilojoules per Kelvin. Okay, so this is how you have to approach the numericals. So we will solve few more numericals in the next lecture. That is lecture number 15. So thank you, one and all.